Have you ever stopped to think about what happens the exact moment you buy something online? You click a single button, and behind the scenes, this massive invisible chain reaction just kicks off. Today, we're going to pull back the curtain and look at how these incredibly complex systems can sense that one click and react to it all in the blink of an eye. Right, so let's really think about that. The second you click buy, your order gets confirmed, inventory is updated somewhere, a shipping label is probably queued up for printing, and boom, an email lands in your inbox. How do all of these different pieces coordinate without stepping on each other's toes? What's that very first signal, that first domino that tells every other system in the chain it's go time? Well, to make all that magic happen, modern systems all rally around one really powerful idea, and it all starts with something we call an event. So, what exactly is an event type? You can think of it as a very specific official name for a trigger. Instead of a system just vaguely knowing, hey, something happened, it knows with certainty an order-submitted event just occurred. Now, for anyone who's worked with databases, this is a huge deal. Think about the old way. You'd have to constantly check a table over and over just to see if a value changed. Talk about inefficient. This whole shift from just polling data to using precise named events, well, that's the secret to creating order out of potential chaos. And these events really come in two main flavors. First up, you've got your external events. This is the first domino. It's something that happens outside the system's control, like you, the customer, placing an order. Then, in response to that, the system creates its own internal events. That's the chain reaction. Things like update inventory record, which then kicks off the next process in line. Okay, so an event has happened. A brand new piece of data, your order, has just been born. But that order isn't just going to sit there, right? It's about to go on a whole journey. So how in the world do systems keep track of that? Let's put it another way. How does the database actually know the difference between an order that's just been placed versus one that's been paid for, or one that's already on a truck out for delivery? It needs some kind of map, right? A map of that item's entire life. And the tool for that job is called a state transition diagram. Honestly, the best way to think of it is like a flow chart, but for your data. It perfectly maps out every possible status or state an order can be in. And just as importantly, it defines the one and only event that can move it from one state to the next. So if we look at our order, the order submitted event moves it into the placed state. And notice, it can't just randomly jump to shipped from here. Nope. It can only go to the paid state, and only when a payment confirmed event happens. This really rigid structure of controlled steps is what prevents all sorts of errors and makes sure the data is always in a state that makes sense. So we get it. Events change the state of our data. But so what? Why does that actually matter? I mean, what does a change from paid to shipped actually do in the grand scheme of things? This is where it gets really clever. That change of state, it's not just a passive little update in a database. It becomes a brand new trigger all on its own, what we call a system event. The instant that order's state flips to shipped, that change is basically broadcast across the entire company, shouting, "Hey everyone, this order is shipped. Time for the next wave of actions." And this points to a really crucial principle in good system design. This stuff isn't random. The idea is that for every important event, there has to be a dedicated process whose whole job is to handle it from start to finish. One event, one complete, self-contained response. And this is where the real magic happens. That one single order-shipped event can trigger a whole cascade of different processes, all at the same time. The notification system immediately fires off an email. The logistics system gets the tracking data. Your customer account page gets updated. All of this is a beautifully coordinated, automated ballet, all set in motion by just one little change in the data's state. Okay, let's take a breath. We have events triggering state changes, which in turn trigger dozens of automated processes. This sounds incredibly complicated and maybe, just maybe, a little fragile. How does a system like this possibly manage itself without just spiraling into total chaos? Yeah, that's the big question, isn't it? How do you maintain control and stability when you've got constant automated change happening everywhere? Well, the answer comes from a field of study you might not expect: cybernetics. The key concept here is something called the feedback loop. And this isn't just some tech buzzword, it's a fundamental principle of how any complex system stays in control, whether it's a living thing or a global shipping network. It's the built-in mechanism for a system to watch itself and constantly correct its own course. You know, the thermostat in your house is the perfect example. We all get this. The thermostat unit itself is the controller. The temperature you want, say 72 degrees, is the set point. The air conditioner is the process doing the work, and the current room temperature, that's the value, being constantly fed back to the controller. If that value drifts away from the set point, the controller kicks the process into gear. Our data systems work the exact same way, constantly comparing the current state of the data to a desired state, and triggering processes to close any gap. So this is really where it all leads. We're building these incredible systems that use events and state changes and feedback loops to become more and more autonomous. And that leaves us with a pretty fascinating question, doesn't it? As these systems get better and better at managing themselves, does our role start to change? Do we shift from being hands-on operators to being architects? Are we moving away from direct control and more towards just defining the right goals, the right set points, and then trusting the systems to figure out the rest? Lots to think about there. If this deep dive helped things click for you, do me a favor and share it with your colleagues. And of course, subscribe for more explainers on the amazing systems that shape our world. Thanks for diving in with me.